9.1 covers sequences, a couple of sequences that we are going to talk about. One being an arithmetic sequence, second being a geometric sequence. We're going to identify the equations and how we can manipulate them and use them in these different types of sequences given realistic situations. First off, we need to know what a sequence is. A sequence is basically an ordered list of numbers. An arithmetic sequence, basically what you need to know about the difference between arithmetic and geometric. The arithmetic sequence, you're going to be dealing with a little bit of plus minus here. So if something is increasing or decreasing by a given amount. Geometric deals with multiplication. Given our first arithmetic sequence, it says identify the correct function for the following sequence. They have 2, 9, 16, 23. So this is an arithmetic sequence as stated above, which means this is increasing or decreasing here. Obviously it would be an increase. So first things first, I'd go ahead and find out what that increase is. And we are gaining 7 each time. Basically what you have just found here is what we call the common difference. So the common difference is 7. Now, in chapter 4, we talked about slope. Slope is basically the rate of change, how much something increases or decreases. And obviously, in this case, it's increasing by 7. Slope, given the equation, and this is the arithmetic equation, also known as slope-intercept form, f of x equals mx plus b. M, that you just found, is your common difference. So I'm going to go ahead and plug this so far into my formula. M, the common difference is 7, and it is next to x. Now, to find out your b value in this, as listed above, sometimes it helps if you go ahead and list off a table. And what you need to know about the table is b is the first term in the sequence when x equals 0, 1, 2, and 3. So 0, 1, 2, 3. When your x value is 0, that is going to give you your b value, which is going to be y here. So when I look over to the sequence given, 2 is going to be the x value of 0. 9, 1. 16 is 2. 23 is 3. So I'm going to go ahead and fill these over to my table. When x is 0, this is basically your table here, guys. So I'm just going to input it over here. When x is 0, y is 2. When x is 1, we get 9. When x is 2, 16. When x is 3, 23. So we've filled in our table. Again, when x is 0, you get your b term, which is 2. That is a positive 2. So I'm going to go ahead and put plus 2. This equation would help be used to find different term numbers, maybe the nth term in a sequence. You will see here shortly in example 2 on how we will use our equation that we just found here and actually apply it to a realistic situation. So given that, example 2. Now, you can't just go ahead and step out and find your common difference in here because you want to note here it does have a little literature behind it here. So it says Cyrus is saving packets of mustard from restaurants to use when he brings his lunch for work. He already had 2 packets before starting collecting them. The total number of packets he had collected each week for 5 weeks is given in the sequence below. So these are the weeks. This would be week 1, he has 5. Week 2, week 3, week 4, week 5. Well, notice we're not starting x equals 0 here. But we can find it in the literature above. It said that he already had 2 before he began. So at week 0, he already had 2 ketchup packets. So filling in my table, at week 0, 2 ketchup packets. At week 1, 5 ketchup packets. At week 2, 8. At week 3, 11. So now we've filled in our table, and we're using x equals 0, 1, 2, 3, as mentioned above. Remember, the first term is when x is 0, you come up with your b value here, which would be 2. So we could easily throw that into our equation down below. Next thing that we need to find out is that common difference. Well, we go from 2 to 5. Gain 3, plus 3, plus 3. Obviously, you can see that pattern there. So the common difference here is going to be a positive 3. Common difference is that rate of change. That's our slope. That's our m value. So our equation would look like this. F of x equals m, common difference, 3, x plus b. b is when x is 0. We get 2, positive 2. Now down below, this is how we would use our equation above. F of x equals 3x plus 2. As stated, it says if Cyrus does not use any of the packets of mustard, how many packets will he have after 12 weeks? I think above I was saying ketchup, I meant mustard, I guess. It's neither here nor there, but what we need to do is go ahead and we need to figure out after 12 weeks. Well, if you look up here, x is talking the number of weeks. Y is talking about, or f of x is talking about the number of mustard packets. So we are going in for x, we are going to put in our 12 weeks. So we have 3 times 12. We gain 3 packets every 12 weeks plus the 2 packets that we started with. We now have 36 packets plus the 2. So we have 38 packets of mustard after 12 weeks. Example 3, I want you to go ahead, pause the video and try to tackle this one yourself. Notice there is no literature behind this, so our first value when x is 0, there it is. So go ahead and pause the video and try to work through this real quick and check back in. Have our table filled in. Have that common difference being negative 4, which is our m value. When x is 0, we get our b value. So f of x equals negative 4x plus 18, giving us option A. Geometric sequence, as stated before, dealing with multiplication here, have a different equation that we will use, and it is f of x equals ab to the nth power. Note that sometimes they won't use n, they may use x. I think on today's worksheet it says x, but it's the same thing. What you need to know about these terms here, A represents the first term in the sequence. B is going to represent the common ratio. Kind of found like the common difference, only we know that it's dealing with multiplication. And N is talking about the term number. If you're talking interest here, compound interest, you could be talking about years. We'll get into a realistic situation on how you're using your exponent here. So the first things first, I'm going to go ahead and knowing that this is a geometric sequence, because if I add here, this is going up by 10, and then I go here, it's 30, so it doesn't have the common difference. So I know then that it's going to probably have that common ratio. And to get from 3 to 15, I'm multiplying by 3 by each time. So my common ratio here is times 3. Now in my equation, the equation that we have is f of x equals a b to the nth power. So I'm going to go ahead and substitute in what I know. I'm going to substitute a and b. A, first term in the sequence. First term in the sequence is 5. So I'll say f of x equals 5. B is the common ratio. So that is 3. So I'm multiplying by 3, and that is to the power of n. Again, just getting in the habit of being able to manipulate that equation for the geometric sequence. So let's identify what's happening here. And we are multiplying by 2, multiplied by 2, multiplied by 2. Common difference here, multiplication of 2. Equation f of x equals a b to the nth power. A represents the first term in the sequence, 5. or your starting point, basically, if you can think of it like that. B is the common ratio, 2, again to the nth power. So I'm going to show you in this next example here on how basically the geometric sequence is used. Here's our realistic example. It says Alice started a new job at an annual salary of $30,000. The company offers her a 5% annual raise. Approximately what will Alice's salary be at the start of her 5th year? So basically, if it's at the start of her 5th year, she has completed 4 years. So here's our formula. F of x equals a b to the nth power, or the power of x. A represents the starting point. Well, what did she start with? Her annual base salary right there. So I'm going to go ahead and substitute that in for A, 30,000. B is going to represent that common difference. Well, the common difference is she's going to have a 5% annual raise. So basically, we're going to have 1 plus the 5% raise, that 1 including that whole number of 30,000. And we need n representing the number of years, in this case being 4 years, because she's only had 4 years. This is the start of her 5th year. So now you have to kind of apply PEMDAS here, order of operations. Well, what would you take care of? You're going to take care of your parentheses first. So I'm going to keep working down my page here. I'll have 1.05%, 1 plus 0.05, and I'm going to go ahead and put my exponent down. The next thing that I would do according to order of operations is take care of my exponent. So again, slide 30,000 down, 1.05 to the 4th power, and we know how to use the power button, that caret button on our calculator. This is what we'd come up with, is 1.34. I'm just going to go ahead and write a couple of them down. Obviously this continues on your page there. I would go ahead and leave that number right into your calculator. That number that you have on your calculator, this number, all you need to do is multiply 30,000 by it, and you would wind up with approximately 40,202.87 cents. So that's where her salary would be starting that 5th year. So that's how you would use your geometric sequence to figure out the salary due to her annual raise. One thing you need to note in this problem, an annual raise is obviously an increase. So that is why I am adding the 0.05. If it was a decrease, well, instead of adding, we would be subtracting 0.05 from 1. So note that on today's assignment. You want to look for, is it an increase or a decrease, and that'll be determining on what you do to your variable 1 when you're dealing with percentage there. This will conclude 9-1 sequences.